Hi, I'm Ifeoluwa. I'll be presenting about CRRA, a cancer risk reasoning agent. Healthcare AI has made remarkable progress in predicting disease risk, yet many systems still function as black boxes. They produce predictions without clearly explaining how those conclusions were reached. CRRA takes a different approach. It performs transparent, evidence-informed clinical reasoning through a workflow-driven multi-agent architecture. A quick disclaimer to note. CRRA is not a diagnostic tool. It is an explainable clinical decision support prototype designed to make reasoning transparent and inspectable. On the left is a simplified view of many traditional AI systems. A patient profile goes in and a prediction comes out. However, with CRRA, which is on the right, the reasoning process is decomposed into transparent workflow stages. Every conclusion is linked to retrieved biomedical evidence, reviewed by an independent skeptic agent, accompanied by confidence estimates and presented through an explainable reasoning trace. So how does this actually happen? The reasoning process begins with a structured patient profile. The orchestrator agent coordinates the workflow and manages communication between agents. The security agent validates inputs before analysis begins. The evidence agent retrieves and ranks relevant biomedical literature from a local ChromDB knowledge base. The evidence reasoning agent identifies evidence-informed risk contributors and interactions between patient factors. The counterfactual agent explores possible lifestyle interventions, while the skeptic agent independently critiques the reasoning, highlights missing information, and adjusts confidence where appropriate. Finally, the synthesis agent combines everything into a transparent clinical report with complete reasoning trace. CRRA was designed with software engineering principles in mind. The system is implemented entirely in Python. The agent communicates through strongly typed pandatic data contracts, ensuring consistent and reliable information exchange throughout the workflow. Supporting biomedical evidence is retrieved locally through an embedded ChromDB knowledge base, allowing the system to operate without external AI APIs while helping preserve data privacy. To improve reliability, the project includes 128 automated test covering units, integration, end-to-end, benchmarking, and observability testing. Before demonstrating the system, I would like to briefly mention that CRRA was developed using anti-gravity. Here, I'm using a representative patient profile, let's say 50, female, let's say 32, smoking, active, moderate, medium, and distal. The system identifies the patient's most significant evidence risk contributors. In this example, we have the hereditary risk through BRCA1 is combined with modifiable factors such as smoking, obesity, and low physical activity to build a more comprehensive reasoning process. These are the obesity, BRCA mutation. Then, rather than stopping at identifying the risk, the counterfactual agent explores practical lifestyle modifications that could potentially reduce modifiable contributors such as smoking, this is it, achieve a healthy BMI, and the rest. Then we have the skeptic and audit review. Instead of accepting every conclusion, the skeptic agent actively challenges the reasoning, identifies missing clinical information, highlights uncertainty, and adjust the confidence level where appropriate. This. Okay. And the last one is the reasoning trace. Here, every stage of the workflow is recorded in a reasoning trace, allowing the users to inspect how information moved through each specialized agent before the final report. Future work will focus on integrating real-world clinical datasets, validated predictive models, clinician evaluation, and benchmarking against established clinical risk calculators. The long-term vision is to combine data-driven prediction with transparent, evidence-informed reasoning to support more trustworthy clinical decision-making. Thank you very much for your time and consideration.